This question is from GATE 2014 Mechanical Engineering paper, Set 1, question number 33. Consider a cantilever beam having negligible mass and uniform flexural rigidity with length 0.01 meter. The frequency of vibration of the beam with 0.5 kg mass attached at the free tip is 100 Hz. The flexural rigidity in Newton meter square of the beam is dash. Let's write the given things first. So it's given that the cantilever beam is having negligible mass and it's having a uniform flexural rigidity. Flexural rigidity denotes E into I. That is modulus of elasticity of the material of beam into area moment of inertia of its cross section. Length of the beam is given to be 0.01 meters. Frequency of vibration Fn, natural frequency of the beam, is 100 Hz. And a mass of 0.5 kg is attached to the free end of the beam. So complete beam is having negligible mass, but a mass is being attached to the free tip. So we need to account for that mass. So let's represent this situation in a figure first. We have a cantilever beam and this mass that is being kept at the free end is having 0.5 kg as the value. Let's solve this. Now, for solving this, we will need to know some standard expression. So this is a standard expression which gives us deflection of this free end when there is a concentrated load on a cantilever beam's free end is nothing but delta. This delta is given as concentrated load at that end, at that point, into length cube divided by 3EI. So this gives us the deflection. W of course can be calculated from the mass that is given, 0.5 kg, which will be m into g. But also we can calculate deflection with respect to stiffness. So it will be W divided by stiffness at this particular point. Now when this mass vibrates, definitely there is some stiffness which is going to produce a restoring force that will bring back the mass. So that stiffness is K and weight that is causing the deflection is nothing but W. So we can equate deflection calculated from these two methods. We have WL cube by 3EI is equal to W upon K. WW getting cancelled. We get K value from here, which is equivalent stiffness value as 3EI upon L cube. From here we can calculate EI. So let's just rearrange and write EI. EI will be equal to KL cube by 3. But we don't know K. We know the length. We don't know K. We can find out K using the frequency given. Frequency is given to be Fn. We can calculate the circular frequency from here. That is omega n is equal to 2 pi Fn, which is 2 into pi into 100, 200 pi. As per the fundamental formula of frequency, we can equate this to omega n is equal to root over k by m. Squaring both sides, we have omega n square into m is equal to k. So finally, let's find out k here. We get k is equal to 200 pi whole square into mass is 0.5 kgs. This stiffness turns out to be 197,392.09. Stiffness unit here will be Newton per meter because it is force per unit deflection. So Newton per meter. We have K. We can now find out EI. This gives us EI is equal to K is 197,392.09 into L is 0.01 meter cube divided by 3. We get the EI value to be 0.065 and unit of E modulus of elasticity is Newton per meter square and I is meter is to 4. So we have the unit as Newton meter square. Let's go back and write the answer. Flexural rigidity unit is already mentioned here. Newton meter square of the beam is 0.065. To learn more about free vibration and dynamic responses, you can refer to the NPTEL video, Module 1, Lecture 36, Free Vibration and Dynamic Response of Continuous Systems from the course Structural Dynamics. It is by Dr. P. Banerjee. He is from Department of Civil Engineering, IIT Bombay. I hope the solution will help you clear it out. Thank you.